Hey everyone, good morning. Long time no see. Let me know if you can hear me well, see me well, and let's get started. Far color. Long time no see. Oh god. This is a really long time no see, far color. I didn't even know you're still following me on Twitter, far color. Yeah, I actually did like 50 live streams for the past 2 years. But these ones are the first ones I'm doing in English. I used to do it in Russian. Este magnifico stream. Oh, yeah, I've started learning Spanish recently, so expect me to use some muy biens and buenos tardes from time to time. Okay, hello. So I'm gonna try to do 2 animations today. One's gonna be sort of 2-dimensional, and the other one is going to be sort of 3-dimensional. So I recently been doing a lot of GIFs. I actually just checked it on Wikipedia, and it's right both ways. So you can say GIF, you can say GIF, you're still gonna be right. So I used to do lots of these kind of animations. They're kind of useless, but it's a lot of fun to do. Some of them are replicas, some of them are the ones I just thought to myself of doing. Lots of different stuff, and one of those were this one. Okay, I'm gonna change the screen. Нет, я не забуваю русский, просто не знаю. Коротше, я все ще можу розмовляти українською. Добре. One of the animations I did was like this one, and some of the guys asked me like, how do you do all those kind of animations? And this one received like a couple of questions about how do I do this. So I'm gonna do this one. I'm gonna show you how you can easily do these kind of GIFs with just JavaScript and the browser, nothing else. No applications, no processing, nothing else. This one is actually based on the idea of Dave, his name is Dave, but his account is Peas and Bombs. If you follow generative artists, you probably should know him. So it's Dave, Peas and Bombs. He has lots of amazing GIFs. Go check out his profile. He's like, I think, one of the most famous guys who do these kind of GIFs, which are usually infinitely looped, and you can just, I think, I don't know, get an LSD and look at his GIFs like I'm doing right now. I didn't get an LSD though, but yeah, go check out his profile. I haven't been to Yandex Subotnik. Yeah, I think it was like 8 years ago when I came to the Moscow, but now it's kind of weird to come to Moscow for me. Anyways, so let's do this rotating balls animation, which I just showed you, and I already lost it. It's been somewhere here. No, not this one. Yeah, this one. So let's do this. I'll show you how you go about creating this one, because at first glance they look kind of complicated, but let's do this. And then I'll show you some Webgl transition in the end, because both of those animations seem to be quite easy to me, and I thought, let's do them both. All right, so to do the animations, I use Canvas Sketch by Matt Deloria. He's also an amazing guy. You should follow him. His handle is Matt Dazzle. And you can go check out his profile and his Twitter, his Instagram. He's a generative artist, I think that's how he goes now. But he also did a lot of open source stuff. And one of the models I really like is a Canvas Sketch model. This is actually the JavaScript sort of reincarnation of the processing of P5 library. So this is just a library to draw GIFs specifically. Not only GIFs, you can do plotter things, you can draw something on a real paper also. But for me, because I don't have anything to draw, on paper yet. I'm just using it to create GIFs. This is a really simple library, and I think it's the most straightforward one. And I like it more than P5 and processing because it actually uses the plain JavaScript, and when you create something with the Canvas sketch, you can then move it to production. You can just use this animation anywhere. It's kind of weird that I think most of the guys who's watching me now are Russian speaking and I'm speaking English. But, well, you know, all the information are now in English, so I think it's better to the whole world entropy to use English language to do those kind of videos. I think I've done plenty of them in Russian now, so I can do some in English. So just bear with my English. Sorry. Maybe I will do in Russian too. So let's start. I have a basic JavaScript file. This is it, actually. This is all you can see on the screen. This is the whole file to start the basic animation with a... Yeah, yay, we have some guys speaking English. Thank you. Because that would feel really weird to speak English with all the Russian speaking. Okay, so this is the basic file that you use to create the animation with a Canvas sketch. It has some settings which just sets like what's the duration of the animation, the dimensions. Those dimensions actually the Instagram story dimensions. If you're interested, so I would change them later to make something more desktop-like. The FPS is the 36. Well, you know that it's better for video compression lately. If you do the animations with 36 frames per second, they will look more smooth, and the videos can use their own compression to do the in between frames. Yeah, I will try to make more streams. It's been a lot of pressure on me because I did so many streams that every single new animation that I make seems so easy to me. It's not worth the stream. I did this kind of thing before. Anyways, let's just run this basic file and see what's that. So to run, I have to install the Canvas Sketch module. I already have it installed, so I'm gonna just run it. And I have to state the name of the file I'm running and open the browser. The stream got. So what it does now, it actually sets the dimension. As I said before, this is the Instagram dimensions, like the iPhone screen dimensions. And then it just draws this. I have the width, the height, and the playhead. The playhead runs infinitely from 0 to 1, from 0 to 1, from 0 to 1. This is the easiest way to loop the GIFs later on, because we have some variable that just runs from 0 to 1. So if you take, for example, sine of this variable multiplied by 2 pi's, then you have it looped continually. All right. What have I been? I've been very sad. Maybe I'm still sad. Maybe that's the reason I didn't do streams later. Okay, so I hope that's easy and understandable for you, because, well, like one of the main reasons I'm doing this stream, maybe to inspire people to try the Canvas sketch and to try to create your own GIFs for the GIFs god and for everyone to enjoy some visuals on the web. And for you to train yourself to do something visual and algorithmic and to try some math algorithms. Hey, nice to see you, everyone. Yeah, I missed you too. So far what we are doing, we're just clearing all the canvas, and then I'm just filling the canvas with a rectangle. The width is the whole width of the, of the canvas, and the height is multiplied by the playhead. So if you just multiply it by this, I'll get the half screen. Well, obviously like this, and the playhead is animated from 0 to 1, so when I multiply it, you just get this smooth animation from 0 to 1. So how do you go about creating those rotating balls? Well, the first thing I thought, it's kinda looks 3D, it's like the balls that are just rotating in 3D. But then, like, every time I see the 3D animation, I think to myself that it might be actually easier to create this animation with a two-dimensional, math, not three-dimensional, because it's too easy to do it with the 3 dimensions, making a balls half white, half black, and then just rotate it. That's too easy. So let's start creating, I would call it moon. I think for me it looks like moon, so I'm gonna create a function called draw moon, which I'm gonna use in a couple of minutes. And so far, let's just start coding here. So first of all, I would like to make it central, like center the drawing pen, imaginary pen of my canvas. So I'm gonna do translate width half, height half, and then I'll remove this. I'll do some small rectangle just to see if it really centers the screen. Yeah, it does. It did. So I'm drawing in the center of the screen. It's not gonna fill the screen faster. It actually still runs at 60 FPS. It regardless of the FPS I set here, but this library, it has the possibility to save the frames, so it can run the animation because we have this playhead which runs from 0 to 1, so you can actually get as many numbers between 0 to 1 as you wish. So if you set like 360 frames, for 1 second animation, it will get you 360 PNGs, which you can then you can do whatever you like with those. But if I set like 10 seconds and 36 frames, I will still get 360 frames with the PNGs. So you can even see, I think I have some example of those PNGs, so I can show it to you. So sometimes I just create straight video from this library, but sometimes I just create this kind of PNGs. And then I just use FFmpeg to create a GIF from them. Because sometimes I want to experiment with some compression settings, FPS or something like this. So that's where the FPS matters. It doesn't actually matter in the browser, it only matters when you try to create a GIF. Yeah, so it's actually almost like processing, because in processing, I think you also have some tools to create frames and to save frames and to create the videos. But here you can create video immediately, because it's a small off topic, but I think they have like Canvas sketch video. And you can get, no, maybe not here. I think I gotta go to docs. Has some documentations, and then it has a lot of video. Okay, frames, save, stream. Yeah, exporting artwork. Yeah, that's what you get it. Exporting. So you can actually export it to PNG, GIF, MP4, SVG, and even the files to draw on the paper with a pen. I haven't used that myself, but it has those possibilities. So if I just set like Canvas sketch and output media, it will output frames, but I can also output videos if I set some other options like this. I think will output video, this will output GIF from my animation, and this will even output some special kind of GIF with a 512 pixels wide. Okay, so this is why I'm using this, because it's really easy later on to create the video or GIF or to export it anywhere. And this part is just straight algorithmic, so I'm not really seeing any API from the DOM, any get context or stuff. I'm just straight drawing into the canvas. That's why I like it. So let's finally start to draw something. I drew the green rectangle. It's not really what I intended to do. Let's draw the circle. So there are a bunch of ways to draw the circle. Actually, like one of the easiest is to use Canvas arc method. It's just drawing the circle actually. But this is a circle that I can't really do anything about, and I'm not really liking it. So let's draw the circle with the points. I will like let num equal 50, and then 4 minus num, create theta, which is gonna be equal, I divide it by num and multiply it by 2 math b. So then I'm getting an angle for each point, and then I like to name it xx because x is too easy. So double x, I think it's much better than 1x. So it's gonna be some radius, it'll be 100. Multiplied by mass sign. Actually, the first one goes with the cosine, but I always mess it up. Cosine of the theta angle, and then yy is a sine. And then I can context. Then I have to start the or is it closed pathos? I keep forgetting that. And then let's see if we really drew something. No, we didn't, because math sign, is it a what? Have I forgotten how to use this? All right, so here we go. Now we have a circle. The rectangle has actually not been centered because its left top corner has been centered. And now we have the circle in the center, and stroke is, you might just want to do something like this, context, line width. This is the actual native DOM API, like Canvas API to draw things. Just like this, make it more thick. So here we go. Now we have a circle. It's actually just 100 points. No, I mean 50 points that are connected on the circle. So if I do this 5, I will get this. Easy. Yeah, I forgot. Sign is actually. Hello. It's all right. We're just getting started. We just drew the pentagon. Okay, so I'll make it 50. So to draw, my first idea to do the rotating balls was actually to create, let's do something like black, it's green, maybe something like this. And I'm gonna try to make a black and white rotating ball now. So first of all, I will draw the white sphere, white circle. And instead of stroke, I'm just gonna do fill. So now I have the white one. Then I'm gonna draw the black one on top of it. It's actually the same code that I just did, but with a black color. So yeah, now the black one is on top of the white one. The next thing I'm gonna do, I'm gonna have a playhead variable, and it changes from 0 to 1. What I want to do is actually to have some other number that's gonna change from -1 to 1. But first of all, let me show you something. Like, let's do this if not here, but here. If theta is more than math b, then let's multiply x by the playhead. And the playhead changes from 0 to 1, remember that. So let's see what it shows us. So it's like we're changing just the half points of the circle now. We're just multiplying them by some number, and it's not really what I intended. Maybe maybe like this. Yeah, it's a bit better with the first going sign. So when they multiplied by, let me make it a bit bigger. When the points multiplied by 0, when the animation starts, all the points to the left are just getting the 0x coordinate. But when they multiplied by 1, which is the end of the animation, which is 10 seconds, they're just getting to their original positions. So what I want now is to multiply them not by 0 or 1, but to multiply them by -1 and 1. All right, some discussion is happening. Okay, so I want to map this playhead inside of this loop to something that is from -1 to 1. How do you go? Let's be playhead. Well, you can use the map function, but in this case it's kind of easier to do just this. So if playhead changes from 0 to 1, this is going to change from 0 to 2, and this is going to be changing from -1 to 1. This is like the manual map range function here. So let's multiply it by pina. And what you get now is, well, it's almost 3D effect. I'm saying almost because it's not really linear now. I mean, it's not really linear in 3D perspective. Of course, it's linear in this two-dimensional perspective, but it shouldn't be linear. So what I need to do here also is to use is-in out quad is-in to make it more physically correct. Well, I think it's easy physically correct, at least from what I see. Yeah, there are a bunch of projects. Is-in out quad. Yeah, this is the function I need. I'm gonna just add it here. It's actually a nice exercise to try to invent your own is-in functions and see how they could change everything. So instead of using the I may just try to do this. Maybe it just works. No, it doesn't, but it's quite an interesting effect, because when it's negative, I think it's going to some, yeah, going to positive. I may try to do this then. Oops. Playhead equals is of the playhead. It's not a good practice to change those kind of variables, but okay, let's try it. So it doesn't really change much, but I think it looks better because it should go a bit slower in the beginning and a bit faster in the middle, and then again a bit slower in the end. And that's what is-in quad is about, actually. It just slows down at the start and slows down in the end. So right now it looks kind of okay. And we actually did this kind of sphere. So the next thing I want to do is to make a hexagonal grid. I could actually draw all the circles in a grid, in a, I don't know how to call it, rectangular grid, but it's boring. And to make it look better, you usually use a hexagonal grid. Where's the animation again? Losing it. Yeah. So if you look closer, they're not actually being hexagonal. They actually, I mean, rectangular. They actually being hexagonal. And I just need to use the square of 3 to get this kind of grid. So let's get on with this. Alrighty. So let's create the grid and oh no, let's first move all this code into the draw moon function. It's gonna draw moon at the XY coordinates. Let's just move all this. because I'm making this translate thing, I will also need to make this to save and restore the context in the end. Yeah, I also have it restored in the end. Boom, boom, boom. What else? What else? Like this. Draw moon. Widths. Let's just check first that the function actually works, which should draw the moon at the XY coordinates. So I would actually need to move the restore and save functions also to draw moon part. Text save translates to the XY coordinates. These I would make constants or something like that, global ones. The playhead goes here, and I think I would also need the playhead. Playhead. Let's call it progress. I'm gonna use it where I'm using it. Boom, 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 here. Yeah, I think that's it. It should just draw. It doesn't because what? Because context is not defined. Yeah, let's also use the context here. Yeah, now we have it. So now we have the function, like the separate one, which just draws the moon at the XY coordinates, and depending on the playhead, it draws the what I wanted to say, the progress of the moon. The other thing I would like to do, it's not actually looping infinitely right now, because when it draws the black one, it starts with the white one again from the start. So what I can do now, like one of the easiest and most dumb and straightforward ways of doing it, I'm gonna create the color 1, which is gonna be white, and the color 2, which is gonna be black, and then I'm gonna multiply progress. Let p equals progress multiplied by 2, and if p less than 1, yeah, like this. Then we swap the colors, and p equals p minus 1. So I created p here. I think I need to better do this. So after this one, I have the progress is multiplied by 2, but it changes from 0 to 2 now. And when it's more than 1, I'm gonna bring it back to the 0-1 range, so that I don't need to change the other code. And I also need to change this. It's not the progress anymore. It's just p equals p multiplied by 2 minus 1. Just mapping p to some other region. It should be okay now. So I'm gonna make this whole animation a bit faster, 3 seconds. Okay, something is wrong here. So I cannot access p before initialization. I knew I would mess it with p because too many p's here. I need to name those vars correctly. So now it almost works. At least it doesn't produce any errors. And what I need to do is to swap the color. Oh, I'm not using those colors actually. So let's use those. Color 1, color 2. So now it actually works. It has a bit of the artifacts, but we can get rid of them later on. But now it actually perfectly looped because we just swapped the colors in the end of the animation, and we have the black on top, and then we have white on top, and it's actually looping continually now without any 3D, and we just used, you know, like 50 lines of code. So the next thing I'm gonna do, I'm gonna create the grid of those. Let's do this. Let grid equals just the array, and then let, I don't know, calls. How many calls do we want? Like 20. Rows equals, doesn't really matter, let's be 22. And then I'm gonna loop the grid and draw the moon on each cell of the grid. Yeah. Let's create the double loop, because we're spending too much time doing this easy stuff. But then again, this is the fun part. I actually enjoy the process of creating those drawings very much. So now I can actually create this grid. I'm gonna do this grid push something. X equals, I don't know, width. We have the width here already. No, we don't. We need to move this whole thing inside. So we have the sketch. When it starts, we have the width and the height of the screen. I'm gonna move it here. So I have the width. We can divide it by calls. And Y gonna be divided. And let's move the radius here as well. Because like this is too much. Let's make it 40. Where the fuck is that now? Ah, yeah, we have. I think we gotta have a move here. We still need to use it in those functions above, or I could just move it. Yeah, this is some refactoring dilemmas I'm facing right now. I'm gonna move this function below. After I created the grid, but before the render, I'm gonna have this function. Yes, now we have the small circle in the center. And now let's finally create this grid. So it's gonna have X, Y, and maybe something else. This is gonna be that'll be height divided by rows right now. Let's see what this grid is about. Yeah, it's 400 items, which are just some pixel coordinates, which looks the same because this need to be the I, the J, and then I need to multiply it by the width and the height, because this part is going to change from 0 to 1, from 0 to 1, and this is going to change from 0 to height, 0 to width. So now I'm gonna have the actual coordinates of each point. Yeah, they're different. And instead of drawing just one single moon, I'm gonna do this grid for each. The context, the width, the height, the playhead, but the coordinates is gonna change. Gx, gy. Now we have a lot of circles. They are rotating at the same time. It's not really what I intended to do because I wanted to make a hexagonal grid. So let's create the hexagonal grid instead. We would also need to change the radius, and they are not equally distributed now on the plane because the height and the widths are different, and I'm just doing the linear interpolation between those. So that's not correct. So I would need the SQ squares 3 create the grid. Actually, when I do create those grids, I often just drew something on paper to see like which kind of coordinates I would need to use. So I would also need something called like width, something I usually call width, which is gonna be just the the distance between each point and horizontal axis, and it's gonna be width divided by cols. So this is just width divided by 20 in this case. Then what I need to do next, okay, let's make it a bit less because my computer starts to get slow, and let's make it like 4, not 40 but 4. So you can actually experiment a lot with those things. This is just like the bug that I introduced to you, but it actually looks fun, and it's not really a 3D event. Okay. So I need to use the hexagonal grid. Think, Yuri. How do we go about this? Let's just draw something. Not even for the sake of the explanation of the hexagonal grid, but for the sake of making it easier to me. Sometimes when I don't have a paper, I just drew in Photoshop. Because, like, save the trees, you know. So to draw, I'm gonna use the pencil tool. I'm gonna make a really big pencil. So hexagonal grid, come on, looks like this. And then we have a point here. I think there are different ways to get those kind of grids, but what I'm usually using, I see that this line of points and this line of points, they're actually on the same x-axis, and this is shifted like half of the width. So this is the width between the points. I just got it with the w variable. So, and then the next line is going to be shifted just half the width. The next thing I need is this distance. So if this width, then what is this? This is actually where the square of the 3 comes in. So if this width, then this is, I think, the width divided by square 3 and multiplied by 2. Yeah, so this is the width multiplied by 2 and divided by square 3. So I just need to put this math here. I'm just gonna make my my squares now a bit smaller. Just gonna change the radius so we could still see them. So we could still see like where the hexagonal grid comes in. Okay, and now the x is gonna be like, how do you call it? I multiplied by w. And then I'm gonna get this whole first line, because this is just the I multiplied by w. All right. And the y is gonna be a bit harder because we need this y multiplied by 2 divided by square 3. And this whole thing multiplied by g, because this is the number of the row I'm going in. This is the number of the column, the x-axis, and then the y-axis. Seems to be good, but let's see. Well, yeah, it's equal now because it goes like the same for each line. But now I will add this offset for the even lines, or for the odd ones. I'm gonna do g2, which is gonna be either 1 or 0, multiplied by width, by the half of the width, because this is the width, and I shift each line half of the width. Okay, it's almost there, but something is wrong. Which is what? Did you spot the mistake already? No, I'm not the OBS dev. But I'm using OBS obviously because I think this is the best software to do the streaming online now. So actually messed up something. I need to look for the errors. Something is wrong here, but what exactly? Oh. Okay. Okay, I need to think about this hexagonal grid. What did I mess up here? This is I actually need to add this to the x, not y, because I'm shifting the x axis. And the plus. Yeah, so here we go. Now it looks almost like what we need to do. It actually looks kind of hexagonal already, but I think I messed up the proportions somewhere. Maybe it's not 2, maybe it's just like this. Yeah, now it looks still not correct. This is how I go about math. I'm just trying to guess the numbers usually. 6 years of math and faculty. That's what you get. Why did I did this mistake? Or is it the correct one already? Not even sure. I'm doing this right now. I think the x is correct, but the y's are somewhat not quite correct. I don't think I know English well, but I'm not sure at all about that. But I think I've just watched a lot of sitcoms and read a couple of books. That's how I got to this level, at least. Okay, we have the mistake. We gotta fix it. And we're gonna be almost there then. Okay, J multiplied by W multiplied by 2 square 3. So I'm just gonna draw things. So this is what I'm doing now. Oops. This is the rectangle and this is W. And then I'm trying to find out this height. And if this is W, then this is W2. And if this is W, then this triangle, it's gonna be what? I think it's 2 divided by square 3. So I'm doing this correct. It's 2 divided by the square 3 and multiplied by W. So it should be correct. But it doesn't, maybe it's correct actually. I'm not even sure. Because we're not really connecting the center of those, but the top left corner. So maybe the top left corners actually do the equirectangle or triangle. Okay. Indeed, these are the skills that I got from like 10 years of coding HTML and CSS. I can do the Udemy course definitely about these. All right, so I think this is correct. Let's at least pretend this is correct. So now what I need to do is to draw those. I'll change this to like 30, so it looks like circles. I can change the radius to, the radius is actually something depending on the width too. So now we see that it's not quite correct because the spheres are touching at the x-axis, but they're not really touching on the y-axis. What we actually can do, we actually can like You know, you can't really do this, but if you have the math diploma as me, you can actually do this. What we're gonna do, we're gonna do this. And now it's almost perfect, right? Maybe even less than that. So sometimes in math I actually do this, and then I like, what is this? And this is actually something like like square root of 3 divided by 2. Oh yeah, this is vice versa actually. Yeah, I think it's just like this. Yeah, that's it. That's how you solve the hard math problems. You just guess. I just messed up this thing. It should have been like the opposite way. Here you go. This is the math. Yeah, engineer 10x. Yeah, exactly. This is exactly it. But this is how it works, you know. When you face the hard problems in your life, you can just, you know, guess the right way. Okay. So now I can do like more rows, like as many rows as I need to fill the whole screen. I can just shift them a bit. What else I need to do? They are now rotating at the same time. I need to create some offset var, offset. So let's, for example, make this offset, let offset equals I divided by cos. So it's going to change from 0 to 1. It's really good thing to do to keep all the vars from 0 to 1, because it's like the, I don't know, the global API of math or math algorithmic API, something like that. If something changes from 0 to 1, you can do anything with that. You can put it in any script, and it's a good practice indeed. So when I'm drawing the moon, I would actually need the progress too. The progress. I can actually just use the g variable, and I'm gonna, instead of gx, gy, I'm gonna just transfer g here, and g will have everything I need inside of it. So gx, gy shouldn't change anything, but it did. Why did it change everything? Why the hell did it happen? Okay, maybe it's because I'm naming all the variables the same way. Draw moon. Then I have draw moon, which is using G. What the hell did just happen? Maybe because I have this offset. I have it. And the grid is empty now. Why did I mess up? Okay. What have I done? Help me. Where did I did this stupid mistake? Global API of math. I think it's just 0 to 1. That's it. You have to pay me now. I'm gonna get you my card number in the end. All right. What? Why is the grid empty now? Because I have 0 rows. For what? Why would I have 0? Why would anyone try to animate something with 0 rows? Yeah, of course, now we have G is not defined because I changed. I love this. Okay, there we go. Now we have it. It's 10 by 10. It's all right. Now I have to remove the console logs because it makes it so fucking slow. Yeah, that's it. It's okay. It works. And I needed to, yeah, use this offset number. So what now I can do inside the draw moon function, instead of using this p at the progress, I'm gonna do something like this. First, I'm gonna progress equals plus G offset. So I will make it again from 0 to 1 because this is the global math API, you know. And it's gonna break everything now because of what? Because grid, it's not G, it's grid now. Yeah, and there you go. Now you have the simplest animation that you can actually have. Because of the easing, my ease in out quad, it just slows down at some point, but it's actually looping infinitely now. You don't see where the playhead goes to the 1, because it goes continually from 0 to 1, and because this is the global math API, this is actually working now. So this is starting to look almost like we need to do. The other thing I would like to do is actually make it all centered on the screen. So to make it centered on the screen, I'm gonna do this kind of thing. When I'm gonna create the grid, I'm gonna do the minus widths, half of the widths, and minus half of the height. And then to draw this thing correctly, I would need first, like, it should be still okay. I just moved all the points, they're gonna be negative now. Like some of them will be negative now. This is actually my extension for the Chrome that I'm using. I have a stream where I'm creating this extension, actually. One of the streams I created in Russian, so but still live coding it. Okay, so I need it centered, so x and y's might be negative now, right? Because minus height divided by 2 minus width divided by 2 should all move somewhere to the negative. But it just doesn't show anything, for fuck's sake. Why didn't it work at all? Like, yeah, it moved all the points halfway to the left. Okay, and what I will do now is a context save. I will move all the drawing to the center. Yes, and it all moved to the center. Now it's kind of centered at the x-axis. Now we're gonna center it at the y-axis too. To make it centered at the y-axis, I would just move this. Why it moves so high, actually? For whatever reason, don't even know. All right, what the hell? We'll figure out that later. It's gonna create more rows, more heights. You can make it more dense. So we preserve the proportions and it's all correct, but it's just not fucking centered because I messed up the math somewhere. I think we would actually need to postpone the Webgl transformation later on because the math occurred to me kind of hard to make it in a live stream and because I'm a bit sleepy, but we are almost there, you know, guys. We're gonna finish this. We will definitely finish this. Yeah, you can do whatever you want with this, and this is just the simple circles, you know. Okay, but the most interesting part for me is the offset part. We're almost there. Boom, 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 boom. I think I just needed to create more rows. That was the only problem there. And for the calls, I would just make it bigger. Let's make it 10. Let's make the circles big. Yeah, that's all right. Now we filled the whole screen. Now we get in there. So the next thing, now the offset is based only on the horizontal position of the of my circle. I can make it based on the vertical position. So now each circle has its state. and it's rotating according to its offset. It's actually, every circle, if you look at it, makes the whole loop continually, but with some kind of the offset. So the offset is actually the key. So the only thing that we need, that's left to do, is to figure out what kind of offset we need here. And that offset should be based on the distance from the center screen. I want to make a spiral. So to make a spiral, you first need to calculate the distance. Let the dist for each of the, let's create the function called dist. It's gonna be just mass script x1. We're just gonna calculate the distance in two-dimensional space between 2 points with the coordinates x1, y1. So it's gonna be the square root of the x1 minus x2 plus y1 minus y2. Yeah, that's it. I have to make the return now. So what I want to do now, I want to calculate the offset as a distance from the center point. Because I already centered the points, like the point in the middle gonna have the almost 0 coordinates, I just need to calculate the distance from the x, y to the 0, 0. So it's gonna be distance between x and y, 0, 0. And I would like this dist to make to be something between 0 and 1, because it's a global math API. So I would need to divide that by x, y, divided by the maximum coordinates I can see on the screen. This is the width half and height half. So now the dist is going to be something between 0 and 1 on the whole screen, right? Because like this is this distance between the center and the leftmost or any corner on the screen, this one. And this one's just the distance for each of them. Okay, so now I can make offset equal dist. Let's see what happens. Yeah, because I'm calling the function and the let's make it distance. Yeah. So it looks kinda interesting, but not quite what I intended to do. It's actually kinda centered, but we have some error again somewhere. Something is wrong, but what exactly? It's almost there. Something on the bottom of the screen is wrong with the math. I would also remove is to make it more linear. What is happening in this corner of the screen? Well, I could make it like this, and it looks kind of okay now. But I don't think this is the right way of solving the problems in your life. So probably I would need to fix this. Okay, what could possibly be wrong with this function? So I'm calculating the distance. Between x, y, which is my coordinates of the circle, and then divided by the something is definitely wrong, but what is? Okay, so this x, y, they're changing from 0 to width divided by 2 and height divided by 2. This is a bit embarrassing, but just a bit. Maybe you already figured out the mistake. XY. Well, the bad thing is that it's almost working, you know, this is the worst kind of bug when it almost works. It's like, why the hell it looks okay? It shouldn't. But it does. Okay. What in the hell is happening here? It's just random. Distance between XY. Oh, I think it's not XY. It's actually between 0 and the width. Yeah, now it works alright. Okay, so now we have it centered. Well, it actually already looks nice, but what I want to do is the spiral. This was the mistake. I just copy-pasted it and left the XY because I didn't need the XY in the end. I just need the maximum distance, and it should be static. It should be independent from the XY coordinates. So what else I could do? To make spiral, I would also need an angle. So I'm gonna calculate an angle now. It's gonna be math at 10, 2, and then I need the X and Y coordinates. I think it's Y and X in that time too. So it's gonna change between minus math pi. So if I divide it by math pi, I would get it from -1 to 1. From -2 to 2, I think. Let's see what it actually returns. What it actually returns, minus pi and pi. Okay, that's all right. I'll leave with that. So I can try to add my offset should not be just dependent by the distance, but by the angle too. And now it starts to look real weird. I think I would also need to use the global math API and make it from 0 to 1. And now it starts to look even weirder than that. I think that because I messed up something with the angles, I think it's too much. Yeah, something is wrong in this region, but you can start already see the spiral now. I think the distance should be a bit more. So now you start to see the spiral here. So the spiral is actually something that is function from the angle that's going to the circle and the and the distance. This is actually already looks like spiral. I just need to make more columns. Yeah, here we go. So now it's like lots of, what's that, 1200 circles animated at the same time, and we have the spiral now. Hello. So that's it. This is what I wanted to show you. That, well, the most interesting part for me is actually the spiral part. It is just the correctly calculated offset makes you a spiral now. We still have this error somewhere here with this part of the circles for whatever reason. I think it's maybe something close to 0, or why would we actually why do we have this error right here? It's only in this part of the circles. Any guesses? Any suggestions? Why do we have it? We could also change the spiral look by this, but this is not too good. By this, you can change the spiral, but something is wrong in this region. This is actually just the left top quarter, like where the both X and Y are negative. I'm getting something wrong when they are both negative. And why do I get it wrong when they are negative? I could also multiply distance by 0 Now we're gonna have an angle part. I think it's because I get something wrong with the angles. Should have been good, but something is okay. Maybe, but I think it's XY. Yeah, it's not YX. It's yeah, it's YX. I mean, it's not XY. All right, that's gonna be the homework, I guess, to find out what was the mistake here. But with the angle, you can actually get it to loop even continually. I think, yeah, the error here is with the angle. I'm doing something wrong with the angle. Okay, I just need, I think I'll just do this. The angle should be between 0 and 1, but I have it between what? Between minus 0.5 and the maximum is, I think, 0.5 positive, right? So it's kinda okay, but it just doesn't loop. All right, so the angles is, I think it's calculated okay, it just doesn't loop. Maybe because I get the offset negatives sometimes, so maybe just something like this. Yeah, I think that was a mistake. For some of the circles, the offset was negative, like just a little bit negative, but then you mess up all the other calculations, and that's it. So I can make this, and now we have it perfectly done spiral now. Just what we intended to do. Just set 4. By the way, 4 is the number of death in Japan, so this is kind of symbolic. All right, there you go. Now we have it. Well, if you're still not bored and not tired, and if we have, I don't know how many guys are still watching me after all these struggles, I can show you some Webgl animations too. Just a simple one. And the funny thing is actually almost the same kind of math that we have here. So yeah, now we could export it. We actually have 25 FPS in the browser, but that doesn't really matter because when I'm going to be saving frames, it's going to save them regardless in the high quality. Okay, so what I wanted to do is to show you just a small image transition that I saw yesterday at one of the awards winning website. So I went to awards. I do this quite often. Simply at 4, yeah. 4. So I went to the Red Color website, and then they have lots of WebGL kind of transitions. The one I particularly liked was the 3D. Where the fuck is 3D? 3D graphics, yeah, right here. So I'm not gonna create something from scratch. This is gonna be just 2 damn lines of code to create this transition. This one, see? I really dig this one. It looks cool. Especially they added also the sound, and with sound it looks even cooler than that. So this is just videos. I think this is just videos yet being transitioned with the shaders. So I have some 3D sketch here. I'm gonna just run it really fast. It shouldn't take more than 10 minutes the whole part. So if you are still here, bear with me. So it's 3D. Then I'm gonna run parcel. I'm not gonna show you all the code. I'm just gonna show you the part that looks like what we really need to see. I would also Google something pen. Yeah, let's use pens. Okay, it seems good enough. And it's free, you know. And I need some other pen that I will like. We all need a pen to like to laugh, maybe. Oh, this one is good. Okay, I'm gonna... These images from the Unsplash, they are quite big, like 3 megabytes. This is just a lot. So I have a 3D scene with a plane with the shaders attached to it. And what I'm gonna do, what I want to do actually. How do I go about this? I just need to create 2 images with the same proportions, and the easiest way to make them square. Let this one be a square, JPEG. No, it's too big. I'll make it smaller because it doesn't really matter the quality. First image is going to be desktop 3D, new folder image, 1 JPEG. And then there goes the second one, my Photoshop skills again. Two. Then I'm gonna open the code finally. And the code is actually the basic 3JS scene. I'm gonna be using 3JS and the plane to show you something on the screen. Normal woman. Oh god, I forgot about the... No, normal woman. I've been broken-hearted lately. I'm actually thinking about switching my sexuality now because men are easier to handle, you know, than the girls. Maybe it will pass, maybe not. Okay, so now I have the... I've been doing this a lot of times in my stream, so I'm not gonna go deep into this. I have the shader. I'm gonna just check real fast if it works for me, like this. Yeah, it does work. This is green now. The next thing I'm gonna do, I don't need this all screen. I have a texture 1, texture 2. I'm gonna try to use it with a parcel. I'm gonna use import image 1 from image 1 JPEG 2. And then I'm gonna type T, I think, new 3. This is the fastest 3JS coding you would see. Load image 1. And then load image 2. And this is gonna be texture 1, texture 2. And now probably if I do like vec4 color equals texture 2D, texture 1, UUV, and then do this, I should see my pen. Maybe not this time because I made some mistake. Texture 2D, I think it's like this. Yeah. So now I see my pen. This is a plane in 3-dimensional space, and I have a shader attached to it, and I'm just making a texture wrap on my plane. Not really cool. The other thing I could do is to make this color 2 and make it like this. Mix color 1, color 2, progress. And I have this variable progress here somewhere. Yeah, progress value. I'm gonna just uncomment that, make it 0 by default, and the progress is right here also in the shader. So color 1, color 2, yeah, it should work now. Okay, so now I have this. Not yet. All right, progress, color 1, color 2, texture 2 here should be. Yeah, so now I have the basic JLSL transition between images. This is boring. But what I saw on this side, this is actually a cool one. They also have videos, but that doesn't really matter for the transition. You can transition between anything. Images and videos, it's just pixels, you know. So to make this kind of transition, what you need to do, I just need to distort both UVs with some weird number. And what's that number going to be? I'm gonna first calculate the vector pointing from the center of the screen. It's this is what reminds me of the previous animation. It's just the same way. We're just calculating something from the center. Because the system of the coordinates is actually in UUV, then the vector pointing from the center is going to be something from center equals normalize, because we need it to be with the global math API from 0 to 1. And then I'm going to do vec2. This is the center of the screen, minus new UV. This is the current coordinate I'm drawing on the screen. So if I try to visualize that, I might actually see something. Yeah, it's like this. It's actually pointing from the center of the screen in each of the directions. It's black on the right top corner because it's getting negative there. In all the other parts you could see you could actually try to think for yourself, like, why is it red here? Why is it green over here? Because the coordinates are 0, 1 or 1, 0. Because, I mean, not the coordinates, actually the direction, because the color is the same in each direction. So now I could distort the pixels with the direction pointing from the center of the screen. Let's do this. I'm going to do this UV1, UV2, and I'm going to do just UV1 equals new UV, like this. Plus progress multiplied by this direction, like from center. Let's see what it changes. I'm gonna comment this line now, and I need to, yeah, see what it does. It's actually kind of cool, and it's ridiculous how easy it is to make, but it's so fucking cool. So the next thing I'm gonna do the same thing to the next image, but instead, because it's transitioning to it, I'm gonna do this. So now it kind of warps from the center. What else I could do? I could do minus here instead of being the plus. I could do minus. So now it kind of warps from the central point and it's kind of going into you. It's cool. Now we could make it a bit less obvious, like make it a bit, I don't know. Let's divide it by 5, for example. Not so intense. And now you're starting to get a really nice cool transition. And this is actually almost what they have it on the website. Just they use this some as isn't function, which goes like a bit with the bouncy effect. And they also have it, I think, on this specific page, they have it only horizontal. And to make it only horizontal, I could just make it this vector from center, just it now pointing in every direction. I need to make it point only up front or downwards. To make it like this, x, y coordinates. So the x coordinates of each vector should be 0. And the y coordinates should be the y coordinates of this vector from center. Let's see what we get with this. Yeah, I think that's it. Because they use the images with the same background, you don't really see it's warping on the background. But I think this is the same thing that you could use here. I think you should also add a bit of the noise here. So if I add JLSL noise, this is going to be the last thing I'm going to do today. I'm going to just add a bit of this noise. Two-dimensional noise. Should I have it two-dimensional? Yeah, why not? Let's make it easy. what it returns me, it's a float. It's just a number. So I'm gonna make it not let, but float noise equals noise, and what it needs, vec2. I could actually do the just new UV here, and now I could multiply both of them with this noise and get it a bit noisy. Well, I think I need to multiply it by 10 maybe to make it more noisy. And here you go, now you have a nice Webgl transition with a noise, and it's going, we could get back the original from center part. It's cool, isn't it? Maybe divided by 5 was too much. Let's just divide it by 3. I think also we have too much noise now. Could divide the noise by 10. I don't know. We could do this like 0.5 plus divided by 10. So it's not so obvious that it's actually noisy. Yeah, now it's noisy, but not as much as it was before. It's cool, isn't it? But it's kind of too easy to make, so I decided not to make the whole separate stream about it. So only if you have lots of patience to wait for me for the more than 1 hour of the stream, you would get this as a bonus content. I hope you like this one. It's really easy to make, you know. We just made like 3 lines of code, that's it. And this is what they do here. It's not easy with the video. Yeah, it looks cool. Yeah, maybe I will put it in some other screen. So it's getting a bit harder on my laptop if I put videos too. Hello everybody. I'm gonna just look at the chat for a couple of minutes and then go live my life. I don't use softboxes, but I'm using I don't know, I have my lights turned on right now, and I think it's okay. I played with the settings for the chroma key a lot, and it works now for me. So it's no softboxes for me, just the chroma key and on my wall. Normalize is a default JLSL function. Yes, it is. JLSL has a lot of vector functions already, like the reflect function, for example. You have it. Yeah, I was glad to see you all, guys. I think that's it for today. I'm gonna stay in chat for a couple of minutes, but otherwise I would like to wish you a really nice day. Thank you, Farcaller, for supporting me with the math. And thank you everybody for getting up so early and spending an hour with me, coding and bearing with my mistakes. Yeah, I think I have the repos for the old stuff I did, and it's actually the same. I change it a bit every time. Yeah, I think you could wait for my course. I just need to, I don't know. I think I need to fall in love again, get a depression. Then when I get a depression, I start to make either streams or courses or something like that. And then I will create my course about something. Yeah. So just wait a bit. The girl would come, she was gonna break my heart, I'm gonna create the course. It's just a matter of time. Thank you everybody. Have a nice day. Be happy.